Today's learning goal is to calculate velocity. Calculate velocity. Okay, so we're going to be defining two new terms. Velocity is how fast an object is moving and in which direction, and speed, how fast an object is moving. So take a moment to review the difference between scalars and vectors from your previous day's notes, and try to think about which of these quantities is a vector and which one is a scalar. Pause the video now. Okay, if you said that velocity is a vector because it has both a magnitude and a direction, then you would be correct. Velocity is a vector. Speed is a scalar because the direction in which the object is moving, just how fast it's moving. So that is a scalar quantity. If you think about the speedometer in your car, it tells you how fast you're moving. It doesn't tell you in which direction you're moving. So the speedometer in your car is telling you the speed of your car. Velocity in physics has a very specific definition, which we have to pay attention to, which is that it includes this direction information. The formula for calculating average velocity looks something like this. Velocity average is the change in position over the change in time. So we can calculate how fast an object is moving by taking how much the object has changed its position over some time interval and dividing it by that time interval. The units for velocity are meters per second. The units for change in position or displacement are meters, and the units for time are seconds. These are the base units for a length and a time. In physics, we commonly use meters and seconds, and so we say, okay, velocity is then in meters per second. If you were working with like miles per hour or something like that, that would be fine as well. You would have your units for change in position in miles, your units for time would be hours, and then dividing them would give you miles per hour, how fast the object is moving in miles per hour. Okay, let's go ahead and try an example. So I want to look at this one. It says, a commuter train travels from Baltimore to DC and back in 2 hours. The distance between the cities is 40 miles. Find the average velocity over the whole trip. Okay, so let's take it step by step. The first step would be to draw a picture of the situation. We should always draw a picture so we can visualize what's happening here. And we have two cities. So we've got Baltimore and we have Washington, D.C. And the train goes from Baltimore to D.C. and back. So we're going to go Baltimore to D.C. and then back to Baltimore. Okay, so very important to remember then that our initial position here is going to be the same as our final position. We'll need that for the displacement. Okay, and it takes 2 hours for this round trip, and the distance between the cities is 40 miles, so here's 0, here's 40 miles. Okay, so 40 miles between the cities, 2 hours to go from Baltimore to DC and back. Okay, so let's go ahead and break down these pieces of information using the appropriate symbols. So delta x is the change in the position, and remember, delta x, the displacement, only cares about the initial and final positions. So here we're going from Baltimore to DC and back. The initial position and the final position are both in the same location. They're both at 0. So the change in the position is 0 minus 0, which is still 0. Okay. Then the change in time, the time interval over which this motion occurs, is 2 hours. We're given this information in the problem, so let's write it down, 2 hours. And we're looking for the average velocity. So V average is our question mark. That's what we're going to be looking for. Okay, so let's go ahead and write down our equation. V average is equal to change in position over change in time. We're going to substitute in the values. 0 miles for the change in the position. The change in time is 2 hours. Okay, 0 divided by 2 is 0 because any number divided by, 0 divided by any number just gives us 0. So it's 0 miles per hour. And since the velocity is 0, the direction here is arbitrary. So take a look at this next one. So this one, I want you to try this one on your own. A car moves 200 meters in 10 seconds. What is the speed of the car? A car moves 200 meters in 10 seconds. What is the speed of the car? Okay, pause the video now. Try this one on your own. Okay, and we're back. So hopefully you tried it on your own, because that's the best way to learn this, is by actually trying this on your own. So let's go ahead and draw a little picture so we can visualize what's happening. It says a car moves 200 meters in 10 seconds. What is the speed of the car? So it's going to go from here, let's say over here, (200 meters), and the time over which it does this is 10 seconds. So let's go ahead and write down the information that we're given. Delta t, the change in the time, is 10 seconds. The displacement of the car is 200 meters. And we're looking for the speed of the car, right? Speed is the same thing as velocity, it's just now we don't care about the direction that the car is moving. So we're going to use the same equation, but we're not going to care about telling anybody which direction the car moved. Is the change in the position over the change in the time. So change in position is 200 meters. The change in the time is 10 seconds. 200 divided by 10 comes out to 20. And the units are meters divided by seconds, so meters per second. So this is our answer. We don't need to tell, we don't need to specify the direction here because they're asking us for speed, so we're good. Okay, let's try another one. Albatross flies south at a speed of 10 meters per second for 90 seconds. If you don't know, albatross, these are birds that are really, it's like a gigantic seagull. It's a bird that lives out in the ocean, and they're gigantic. Look it up, look up a picture of an albatross, they're pretty cool. Okay, so an albatross flies south at a speed of 10 meters per second for 90 seconds. What is the displacement of the bird? The bird is the albatross. Okay, so pause the video now, try this one on your own, and then I'll work out the solution for you. But try it first. Okay, hopefully you tried it. Here we go. So first things first, we're going to write down, we're going to draw a picture. Let's draw a picture. So imagine here's the albatross. It doesn't have to be a very good picture. We just need to like visualize what the problem is telling us. It's telling us that the albatross is flying south with a speed of 10 meters per second. Okay, so its velocity is 10 meters per second south. And this is supposed to be a top view of the albatross, by the way. The tail is over here, these are the wings, and that's the head. Okay, so it's flying south at 10 meters per second for 90 seconds. So delta t, the change in time is going to be it's going to be 90 seconds. And the speed of the albatross, with the average velocity of the albatross, is then 10 meters per second south. And then we're looking for displacement. They're asking us what is the displacement of the bird, how far did it move, and in which direction. So this is what we're looking for. Again, we're going to use the average velocity equation. So the average velocity is equal to the change in the position over the change in the time. And then we're going to substitute in the information that we were given. So 90 seconds goes in for the time, 10 meters per second goes in for the velocity, and we're looking for delta x. So let's try it. We have to do a little bit of algebra here. So we're going to put in 10 meters per second for the average velocity. Delta x we don't know, so we're just going to leave it as delta x, the change in the position in our equation. And then the time is 90 seconds. Okay, so now we have to solve for this unknown, delta x. We're going to try to get it by itself on one side of the equation. So right now it's being divided by 90. We need to somehow undo that division. So try to think about from your algebra class, how do you undo the division? You multiply both sides of the equation by 90. So multiply by 90. Whatever we do to one side, we have to do to the other side. Multiply by 90. And so now the 90 and the 90 on this side will cancel, and we're going to be left with delta x by itself. And so delta x, the displacement, is equal to 90 times 10, and 90 times 10 is 900. And the units for displacement here are, since it was meters per second, the speed, then it's going to be meters for the displacement, and 900 meters, remember the displacement is a vector, and we're being asked for the displacement, so we should specify direction. Which way is the bird flying? It's flying south, so its displacement is also going to be south. So this is our answer, 900 meters south. That problem is a little bit more challenging because we had to do a little bit of algebra to get to our answer, but still, the key here is always to follow the steps, draw a picture so that you can visualize what the problem is all about, write down the given information, write down what you're looking for, identify that, and then look to see which equation has all of these different parts, right? So velocity, velocity, displacement, displacement, change in time, right? So this is the appropriate equation to use. We have all the information we need except for one, which is what we're solving for. And then we're going to substitute in our values and solve. We might have to do a little bit of algebra to solve for the missing variable, delta x. And then that's it. Okay, great job.